All right, let's talk about some radicals and the basics of them. So a radical is anything with this radical sign right here. That just means that you're working with a radical. It's a square root, cube root, anything like that. The number underneath the radical sign, in this case it's A, is called your radicand. And then the number outside is called your index. If it's not present, then your index is automatically 2 and you're working with the square root. So the ones we're working with in this lesson is going to be the square root that doesn't have anything, the cube root will have a 3, and the fourth root has a 4. So let's talk about some solutions to these. So if you have, let's say, 4 and you square it, you get 16. But let's say you square negative 4. You also get 16. So when you're taking the square root of 16 and looking for all possible roots, you're going to want the plus or minus 4 because positive 4 and negative 4 both give you 16. Now, if you're looking at cubes and you take 3 and cube it, you're going to get 3 cubed is 27. But if you take negative 3 and cube it, you actually get negative 27 because that's negative 3 times negative 3 times negative 3, and that's a positive, positive, positive. So when you take the cube root of a positive 27, you only have one solution. There's only one way to get 27 when you cube. And same way if you take the cube root of a negative 27, you get negative 3. So if you have an even index, you're going to end up with plus or minus. But if you have an odd index, it's either going to be the positive version or the negative. There's no in between that. So let's talk about simplifying the radical. Let's take negative 3 fourth roots of 567. So notice we're working with the fourth root. That's what the 4 right here tells us. So perfect fourths. Some perfect fourths are 1, 16, 81, 125, 216. And actually, I don't believe it's 216. Now let I look at that. Oh, yeah. 81, 256, 625. I was getting my cubes and my fourths confused, so make sure you keep those straight. What you want to do is you want to break up this radical into the product of one of these perfect cubes times something else. And if you notice, if you look at 81, 81 goes into 567 7 times. 7 times 1 is 7 times 1 is 7, 7 times 8 is 56. So you can take the fourth root of 7. You can take the fourth root of 81. It's 1, 2, 3. And the fourth root of 7 stays under. And then you just multiply to get negative 9. Fourth roots of 7. And that would be it. This is your answer right here. Voila, it's all simplified. Let's look at another example. And I'm doing examples that kind of resemble the ones that I left for you to do for your homework. So when you have a variable, you want the power of the variable to be a multiple of the index. So in this case, we're working with an index of 2. So perfect squares, we have 1, 4, 9, 16, 25, 25, 36, 49, on and on and on. When we break this up, we want to break this up into the product of a perfect cube and something else. In this case, it would be 36 and 7. K to the 5th, the biggest multiple of 2 that doesn't surpass 5 is 4, which means you need a k to the 1 over here. 36 times 7 is 252, k to the 4 times k to the 1 is k to the 5th, and now you take the square root of 36. And when you take the square root of the variable, you just divide the exponent by the index. So 4 divided by 2 is 2. 7k stays under. And then 3 times 6. And voila. That would be it for that one. And let's just do one more. It's a cube root. So we're going to do the example. We're going to do the cube root of negative r to the 14th s to the 9th. So the perfect cubes can be positive or negative. So 2 cubed, 3 cubed, 4 cubed. So break this up. Your index is 3, so you need them to be multiples of 3. 14 is not a multiple of 3, but the biggest multiple of 3 that doesn't pass 14 would be 12. So this is negative 1 r to the 12, r squared. 12 plus 2 is 14. 9 is a multiple of 3, so you can leave that one alone. When you break these up, you're going to put the perfects in this box over here. So negative 1, R12, S9. And then the last one is going to go in the other one, and I call it the leftover. Cube root of a negative 1 would be negative 1. Cube root of R12, we'll take 12 divided by 3, you get 4. Same thing with cube root of S9, 9 divided by 3, which is 3. And this is fine, or you could just go ahead and do negative 1 times r to the 4th, negative r4 s cubed, cube root of r squared. And you just want to be careful with the exponent and the index. Make sure they're not too close together. So I just leave a little bit of an extra space in between them, but that would be your answer. And that would be it on how to do that one.